Hello, my name is Jeremy Meeks, and today I'll be discussing suspended particulate matter as a health hazard. This will include sources, health effects, and control. This is a final health hazard project for General Agriculture 711 for spring 2012. On the agenda for today, I'll be discussing a quick introduction to particulate matter. Then we will move on to causes and sources for particulate matter. Also, we'll discuss health effects, some regulations that are in place in the United States to protect us from particulate matter, some control methods we use to prevent particulate matter, and then a quick conclusion. Listed here is a definition of particulate matter that is found at the Environmental Protection Agency's website. They list particulate matter as a complex mixture of extremely small particles and liquid droplets. Particle pollution is made up of a number of components, including acids such as nitrates and sulfates, organic chemicals, metals, and soil or dust particles. Particulate matter is usually designated by its size or diameter of the actual particles. We usually say that particles less than 100 micrometers in diameter have the ability to be suspended in air. When we consider the total range of particles, this is known as total suspended particulates, or TSP for short. We also specifically designate PM10 and PM2.5, which is particles less than 10 micrometers and 2.5 micrometers. Particulate matter suspended in air can be easily inhaled. It can have negative health effects on our respiratory system. Below we can see a diagram of what PM2.5 and PM10 look like in relation to the size of a human hair and a particle of fine beach sand. Particulate matter can be generated by a wide variety of sources. We usually classify these sources as point sources and non-point sources. Point sources are those that can be traced back to a single point, such as automobile exhaust, a manufacturing site, or a smokestack. Non-point sources are less easy to identify. These can be fugitive dust emissions from large agricultural fields. They can also be smoke from natural fires. Particulate matter can be made up of a wide variety of chemical constituents. Below is an example of a few types of the commonly recognized constituents. This includes organic dust, asbestos fibers, lead, especially from leaded gasoline, diesel exhaust, crystalline silica, cadmium, which is a highly toxic metal, and it can also be any suspended solid, liquid, or even biological organism. This is a chart that shows some common particulate matter and the sizes that they are often found in. On the bottom, you will see a scale running from very small diameter all the way up to 100 micrometers on the right. We can see that commonly found dust, such as coal dust and cement dust, are relatively large, but are still considered a health hazard as they can be below PM10. On the left-hand side of the chart, we see some very, very small particles such as biological agents, viruses, and ions. Particulate matter may have many negative health effects for us, especially the fine particles that can be easily inhaled but may not be easily exhaled. Studies have shown damaging health effects including decreased lung function, asthma, poisoning, especially from highly toxic particles such as cadmium, lead, and other metals, increased risk of heart attack, irregular heartbeat, premature death, or pneumoconiosis, which is sometimes known as coal worker's lung or dust in the lungs. When we breathe in particulate matter, many of the larger particles may be trapped by our upper respiratory system. This can include mucous membranes, nasal hairs, or the trachea. However, some particles, especially the very fine or small particles, may reach deep into the respiratory system and become lodged. They may even reach as far as our alveoli, which is the area of the deep tissue of the lungs where air exchange takes place. This is where the most damaging effects can occur. In addition to the primary health effects on our respiratory system, particulate matter can also result in secondary health effects, which do not directly affect our bodies but have negative health effects. This includes reduced visibility due to haze from the particulate matter, as seen in the image below, machinery fouling, especially during heavy wind erosion events, where machinery such as tractors and automobiles may become clogged with heavy dust loading, environmental damage or deposition. This is when particulate matter essentially gets deposited into areas such as rivers and other water bodies where it may have toxic effects for the aquatic ecosystem, and also aesthetic damage. Particulate matter results in acid rain during precipitation events. This acid rain may over time degrade buildings and monuments, especially those made of limestone and other basic materials. Because of the recognized health effects from particulate matter and other air pollutants, the United States has passed several regulations to help protect us from particulate matter. One major piece of legislation is the Clean Air Act of 1963. Although this act was passed in 1963, it has been amended in 1970, 77, and 1990 to include major changes and updates in technology. This act holds the power of law. It essentially gives the United States government the ability to take legal action against polluters. This act is designed to reduce harmful air pollution because of its negative health effects. This was the first U.S. law in history to allow for citizen suits. This gives citizens the ability to sue corporations for exceeding guidelines for pollution. This was a major turning point in U.S. law. The Clean Air Act requires large sources of pollution to obtain operating permits in order to release pollution. One example of this is the power plant in Holcomb, Kansas. In Holcomb, they are trying to build a new coal-fired power plant to supply electricity to residents in that area. It took them more than 2 years of redesigning and resubmitting to finally obtain an air quality permit from the U.S. EPA. This can be a very time-consuming process. A major part of the Clean Air Act is the National Ambient Air Quality Standards. This is the part of the Clean Air Act that establishes numeric standards for 6 criteria pollutants. These pollutants include carbon monoxide, lead, nitrogen dioxide, ozone, particulate matter, and sulfur dioxide. We can see the quantitative standards for particulate matter below. PM10 has a 24-hour average concentration of 150 micrograms per cubic meter, while PM2.5 is much lower at 35 micrograms per cubic meter. This is the 24-hour average that must be met by localities. This is the ambient air as opposed to the concentration located at a specific source. In addition to regulations that pertain to the ambient air or the overall air quality, there are also regulations in place that protect us in the workplace. A primary regulation is the Occupational Safety and Health Administration's permissible exposure limits. This is exposure to a certain chemical constituent, including particulate matter. These regulations also carry the power of law and are usually expressed as an average 8-hour concentration throughout the working day. In addition to the OSHA guidelines, many other guidelines have been developed, but are not considered regulations as they do not carry the power of law. A primary example of this is the National Institute of Occupational Safety and Health's recommended exposure limits. These limits are often lower than the OSHA limits and are based on more recent scientific literature and are more often updated. Many industries may voluntarily choose to use NIOSH recommended exposure limits instead of the OSHA limits. Another commonly used guideline is the American Conference of Governmental Hygienists Threshold Limit Value. In order to enforce these regulations, it is necessary that we do sampling of the air to determine the concentration of particulate matter at a certain time. Below, on the left, we see an example of an outdoor sampler. This instrument includes a pump to draw air through a filter for a given amount of time. After the given amount of time, the filter may be weighed to determine the amount of dust collected on the filter. This mass of dust can then be correlated to the amount of air that came through the filter during a certain amount of time to give a concentration expressed as mass per volume of air. The other two images also illustrate the same technique but used on a personal level. These may often be used to test a worker's exposure in a work environment. When working in areas of high concentration of particulate matter, there are several ways to protect ourselves from inhaling many of the particles. The most common form of protection comes in the form of a face piece or a dust mask. The two most common types of dust masks are a negative pressure respirator and a filtering face piece. The filtering face piece is the most commonly seen in dusty environments, but it does not protect as well as a negative pressure respirator. The main drawback of these methods is that they must be properly fitted to ensure no air leaks. They may also produce a strain on the worker's respiratory system, so it is important that the worker be healthy enough to withstand the extra strain on their respiratory system. Now we will discuss some ways for industries to control their emissions of particulate matter. Some of the commonly used types of control methods are fabric filters or baghouses, cyclones, electrostatic precipitators, wet scrubbers, or gravitational settling chambers. In the following slides, we will illustrate a few of these examples. Seen here is a fabric filter or baghouse. This is the most commonly used method in industry to control particulate matter. This is because they can achieve very high efficiencies and can be used for a wide variety of dust. The major drawback to these methods is that there can be a potential for explosion if not properly maintained. Another commonly used method of particulate control is cyclones. Cyclones can achieve very high efficiencies, but are mostly used with larger diameter dusts. Below is an example of what a cyclone may look like in industry. Electrostatic precipitators, or ESPs, are another method that is used in industry. These are highly efficient, but only used with certain types of particles. The particles must be electrostatically charged in order to work properly. Finally, after watching this presentation, we can see that particulate matter is a primary health concern, especially particles less than 10 micrometers in size that can be easily inhaled. Particulate matter has been proven to have negative health effects on our cardiovascular and pulmonary systems. We also saw that particulate matter can be generated by both natural sources such as fires, as well as industrial sources such as smokestacks. We saw that several regulations exist in the U.S., such as the Clean Air Act and OSHA's permissible exposure limits, that help protect us from particulate matter. As a result of these regulations, many control technologies have been developed. I hope after watching this presentation, you have a greater understanding and appreciation for the health effects of particulate matter. Thank you for watching, and I hope you enjoyed the presentation.